Good morning, good afternoon, good evening, depending where you're based. Welcome to the open source news of the 7th of April. My name is Henrik Rexed, and I'm welcoming you to the open source news. OpenFeature is an open standard for feature flag management, created to support a robust feature flag ecosystems. Open features rely on an operator, so the configuration are stored in custom resources definitions, and flag evaluation can also be centralized as a sidecar or a headless service. Plans with OpenTelemetry support will mean that feature flags metadata can be attached to our distributed traces, logs, and metrics, providing the ability to quickly determine the impact of a new feature on our application. Grafana Mimir. Grafana has just released a new project named Mimir. Mimir is an open source software project that provides a scalable long-term storage for Prometheus. Mimir will resolve the scaling issue related to Prometheus by offering horizontal scaling. Fluent Operator. It's not a recent project, but some recent update has been made on the operator. Initially named Fluentbit Operator, the Fluent community has recently renamed the project into Fluent Operator. If you're looking to easily maintain your Fluentbit and Fluentd deployment and easily upgrade and maintain your logstream pipeline, then this project will be very interesting for you. New OpenTelemetry Sampling. Currently, OpenTelemetry provides several samplers when producing signals. So we have, as of now, always on sampler, always off, parent-based, and trace ID-based ratio. To provide more consistency in the way we are sampling our signal, the OpenTelemetry community has worked on a specification introducing new sampler. The sampler has not been implemented except in Go, and it's under construction in a Java language. Meshery is a very interesting project created by Layer 5, designed to manage service mesh. It relies on several features: service mesh, pattern, helping you to deploy and manage your configuration of your service mesh. We have a SMP, service mesh performance, that will help you to test your service mesh settings and validate them. It also provides a map of your Kubernetes components and mesh configurations, the mesh map. Alright, so now we have shared few news, especially one related to the sampler, the new samplers available in OpenTelemetry. It would be great to have more insights, and for that, I have the honor to have Michael Ozenblas with me. So, hi Michael, how are you today?
And good day to you, Henrik.
In today's breaking news, we shared news related to samplers that would be soon available in most of the language of OpenTelemetry. The concept of sampling could be quite obscure for our community, so could you remind us what is the value of sampling, especially when you produce signal using OpenTelemetry?
So let's maybe step back a little bit just to set the context here, and that is OpenTelemetry is capable of representing and routing different kinds of signals, so traces, metrics, and logs. Traces are already in GA, and this is really what we are talking about here in this context. The trace collection and what of those traces, those spans, actually ends up in the back end where you then would query it, visualize it, and so on. And you essentially have two options, right? You can do this sampling, essentially selecting certain spans that actually should be ingested, and the motivation is obviously that you reduce the volume of data so that you don't ramp up costs too high. You can either do that essentially where the traces originate, so in your source code, meaning you are using the SDK, which means one of the 11 programming languages that are supported by OpenTelemetry, or you can do that at sampling in the context of the OpenTelemetry collector. OpenTelemetry collector has for different signal types, so-called pipelines that typically consist of receiver, processors, and exporters, and where at least two of those samplers, the tail and the probabilistic one, are available as processors. So depending on how you're using OpenTelemetry, you have these two options, either through the SDK or through the collector. I think you are specifically talking about the SDK option there.
Yes, correct. I think it's a good point. You just mentioned sampling at the collector level. What is your recommendation? Produce as much signals from the code and then make the sampling decision at the collector level? Or it makes also sense to do part of the sampling at the code level and the other part at the collector?
Right. I think a number of factors play into that decision making, and that is, on the one hand, if you have a setup where you own the source code and can, instrument as you like and change anything as you like, that's one way. Versus you might not own it. You have an interface there, and the only way to get data is through the collector. The collector has the advantage that you can essentially, through a configuration change, as the collector runs, change certain things. So, for example, if you say, okay, I'm using currently this backend, and I'm also want to ingest traces into another backend, then you can do that by changing the configuration of the collector, which is a little bit harder to do in the source, right? So there are a number of factors in terms of flexibility, in terms of what you own and what you can actually change that may be the dependency there. The other thing is to consider what actual samplers are available, right? As I mentioned, currently in the collector, there are only these two. In the SDK, you have the challenge that not every programming language, not every SDK has the same support for the various samplers. So it pretty much depends. If you happen to use one of the programming languages that are already supported, then great, you have that freedom. If not, then you either can wait or use the collector there. So a number of different things to consider to make a decent choice there. But without sampling, to be honest, you cannot or you should not do that without sampling, right? Ingesting every trace and every span is probably not a good idea in production. At
the end of the day, we have lots of volumes and lots of data to manage. And it's always good to have, lots of data, but usually data comes with a price. The tricky part is when you start sampling and you usually ask yourself, do I sample too much or not enough? Unfortunately, there are no recommendations on the market yet, so we need to make this sort of testing exercise. Is there a validation or testing process that could help us improving our sampling settings?
I think it's a little bit tricky because to step back a little bit, the challenge really is with the sampling, right? What do you keep, right? How do you know that when you only pick certain spans, that those are the relevant ones, right? It's kind of like in hindsight, it's kind of clear, we should have kept this or that. But can you make educated guess? How well do you know your workload to, at the end of the day, have something useful, right? You want to have actionable insights, being able to say, oh yeah, this is this particular microservice, the payment service or whatever that causes the issues and has a increased latency or whatever the insight there is. And I think that's the tricky part. The better you really know what's going on, the better choices you can also make in terms of what sampler to use. I haven't seen much formalization or automation around that yet. I think it comes down to a lot of experience with those things, and probably also experimentation to see how certain samplers work with certain workloads.
At the moment, we are focused on bringing tools that help our community to instrument and building measurements out of their application and infrastructure. But at a certain stage, we would probably want to have sort of an indicator that will measure the level of observability, the instrumentation coverage of our platform or solution. This indicator could, I think, help team improving what they are instrumenting at the code level. Have you already thought on how we could calculate that type of indicator?
I think the challenge here really is to practice as you go and really collect these kind of experiences in that context, right? You really want to do the apply it and also share it in the community. I think there's still a lot of work ahead of us, and hopefully now we're in a position that with the increased availability of all this tooling that we can actually run more experiments and share these results there. So I wish I had a better answer, but that's, I guess, where we probably are. It's still relatively early days.
So at the end, I think it's a call to our community. So let's try all those first various samplers and share our experience. The community needs feedback to improve the OpenTelemetry support. And then if you have any idea on how we could calculate such indicator or ratio, please let us know so we could maybe share it and get feedback from the community as well. So thanks, Michael, for your insights and taking the time with us today. See you soon. Bye.
All right. Thanks, man. Bye now.
Here are the books and blogs of the week. Starting with a blog, How to Best MTT Metrics to Optimize Your Incident Responses. It's a blog written by Alex Evelöf. Second, Getting Started with Fluentbit and OpenSearch. Then there's a beginner guides for OpenTelemetry provided by Logs.io.
Here is the weather forecast for the week of the 7th of April. Java version 1.12 for traces stable. Metric is in an alpha release version and logs is in experimental. Node.js is version 1.11 with all the community package in 0.28. Tracing is stable, metrics is under development, and logs is part of the roadmap. .NET 1.10 traces are stable, metrics is in alpha releases, and logs in a beta release. Python version 1.10 traces is stable, metrics is under alpha, and logs is experimental. Go version 1.6.1 traces stable, metrics is in alpha, logs is under construction. PHP, an alpha version for tracing, metrics and logs are not implemented yet. C++ version 1.2.0 traces and public release, metrics in dev, and logs is experimental. Erlang, tracing is stable, metrics is alpha, and log not implemented. Rust, tracing is in beta, metrics alpha, and logging not implementing. Swift, tracing beta, metrics is alpha, and log not implemented yet. On the OpenTelemetry collector, the collector is in version 0.48 with all traces stable with all the various features, metrics is also stable, and logs is in a beta version. On the operator, the release number 1.0 is available, covering all the support related to the OpenTelemetry collector.
That's it for the open source news of the week of the 7th of April. Thank you for watching, and don't forget to like and subscribe to the channel as well. See you soon for the next news.